So it's given that the static friction between mass A, the block A, and table is 0.20, and the kinetic friction between A and table is 0.15. This is a frictionless pulley here, and this is a block of weight 22 Newton, which is B, block B. So when the first part of the question is find the minimum weight of block C. So C is another block that is on top of A, and we have to find the minimum weight of that will prevent uh, A from sliding down. Because of B and because of this frictionless pulley, the kinetic friction, the static friction may not be enough with only A. So another block of some weight C has to be on top of A, and we have to find that the weight of that block C. So basically when it's not sliding down, 22 will be equal to the normal force. The normal force is applied by the weight of both blocks. So basically that would be mu s times the weight of both blocks. So that is 44 plus something which we don't know. So we can just write that C maybe. So we have to find what is the value of C. So C will be 22 divided by 0.20 and then minus 44. So that's 66 Newton. That will be the minimum weight of block C, because if block C has a weight less than that, what will happen is this side will be less than 22. As a result, there will be an acceleration, downwards acceleration this way. So that's the scenario. So C has to be minimum of that weight, which is 66 Newton. Now the second part says that if block C is suddenly lifted off A, what is the acceleration of block A if coefficient of kinetic friction between table and block A is 0.15? So C is lifted off. As a result, the normal force is now less because it is only now for A. So we have to find what is the acceleration. So if we write it again, this is 22. Now what we should do is we can write I don't know, B m maybe times G. So this should be the mass of B, not the weight, and that gives the Bm times A. That will be the acceleration. Let me rewrite this thing. So basically now what should happen is 22 minus 0.15. So kinetic friction, now this is kinetic friction, we are using the value of kinetic friction, times 44. That will give the acceleration. So that subtraction will be the acceleration. So whatever the force acting downwards here and the force that is stopping that, trying to prevent that downwards acceleration, that subtraction will be equal to basically total mass of B plus mass of A times acceleration. Basically that's what it will be. So 22 minus 0.15, we want to find the acceleration, times 44, maybe I will give a times sign here, and this mass, these two mass will be 22 divided by 9.8, and so 22 plus 44 divided by 9.8 times A here. So our A now becomes, from that we get 2.29 meter per second square. So basically what's happening here now is this force is less, this block is lifted off. As a result, the normal force is now less than that. So that will result in an acceleration of A towards that direction. It will start falling off. This, because this weight is more than that normal force there, so the subtracted value will be equal to the mass, combined mass, because both of the blocks will have the same mass. Both block B and block A will have the same acceleration. So sum of the total mass times acceleration will be the subtracted value of this force and this force. It's the normal force basically. So this weight minus the normal force, which is of course weight times the kinetic friction in this case, because this will already start moving when C is lifted off. So we have to use the kinetic friction coefficient.